Welcome to our tour with the Worldwide Telescope. Does anyone really know what time it is? Time is central to our everyday lives. However, as you'll see in the next few minutes, there are subtle variations in the methods by which we actually measure the passage of time. We mark time based upon the duration of events in our physical world. The day has always been defined by the amount of time it takes for the sun to set and return to its place above our heads. The day is then divided into 24 hours, each hour into 60 minutes, and each minute into 60 seconds, concepts we inherited from the ancient Babylonians. If, over the course of a year, we were to take a picture of the sun's location in the sky at the same time every day, and then stack these images together, what would we see? If the axis of the Earth were not tilted, and the Earth's orbit around the sun were completely circular, then we would expect to find the sun in the same spot on the sky every day. However, this is not what we see. This beautiful shape on the sky is called an analemma. The Earth's axis is in fact tilted, and, while the Earth's orbit is in fact very nearly a circle around the sun, it is slightly eccentric, as you can see by the orbit deviating slightly from the radius of the opaque circle. In this view, we are always aligned looking straight through the Earth towards the sun. Notice how, over the course of a day, the background stars drift across the screen, marked by the lines relative to the green star. Because the Earth moves around the sun a tiny bit each day, the time it takes the sun to return overhead, which is called a mean solar day, is actually longer than the time it takes for a background star to return to overhead, which is called a sidereal day. The difference is about 4 minutes. In fact, due to the advances of atomic clock technology, which count the fluctuations of cesium-133 atoms, we're able to measure the passage of time to extraordinary precision, and actually measure the slowing in the Earth's rotation rate. Thus, seconds defined from astronomical processes, such as the dynamics of the Earth and the Sun, change relative to seconds measured from concrete physical processes, such as the fluctuations of individual atoms. Using our very accurate clocks, we can actually measure the difference between what we physically measure as a day and what we astronomically consider a day. Actual changes in the length of the day are only a few hundredths of a second over several thousands of years. However, the cumulative effect of having every day slightly off means that over time this effect will build up. This cumulative discrepancy between what we would measure with atomic clocks and our solar day is called delta T, and can be as much as 8 hours several thousands of years in the past. Zooming into our most recent measurements with our atomic clocks, we can also see the need for leap seconds. We see the length of the mean solar day plotted as a function of the past 5 decades. Notice that the day has changed a couple of milliseconds. In fact, we can even see variation on seasonal timescales. If you've enjoyed this video, check out the accompanying article at the link below. If you're interested in science, and astronomy in particular, check out our blog at astrobytes.com, where we digest a scientific paper daily. Thank you for watching.